What the hell? Hi, tech nerds. This should have disturbed you, I hope, and at least woken you up. Why did we play you screams? Well, it's the most universal thing that comes out of your mouth. Everybody screams. Everybody's heard screams. It's the first thing you do when you're newborn, and yet we don't understand it at all. So I'm going to tell you a little bit about it. As you could hear, it grabbed your attention immediately. If it didn't cause you to pay attention, there's something wrong with you, and you should come see me. They're emotionally engaging. You heard very frightening things, positive things, Europameisterschaft things, sexual things, Teamgeist things. So it's a very universal vocalization. It's effective. And so one of the things we try to do as brain scientists is understand how do we work? What makes us tick? Now, I want to show you a few minutes of stuff on regular research to then go to the clickbait word as what makes us click. Now, I'm sure as tech nerds, you're hoping I'm going to explain to you what makes us click. But I'm going to explain to you what makes us click with each other. How do we synchronize, and how does that work? So what do we do as scientists? We do this. We take something apart into its smallest thing. So this is non-ironically a Volkswagen. And we put it into its smallest constituent. So that's really what science is. You break something down into small pieces. You try to figure out how the pieces go together and how they work. So this is regular research. Now, of course, what we would like to understand isn't just something as boring as a taken apart Volkswagen. We want to try to understand something like this. So this is a picture from TOA 15. So something that's multisensory, that's interactive, that's contextually dependent, so real-life interaction. Of course, that's what science ultimately strives to understand. We want to see things that are emotional. Everybody likes emotion. That are cute. How can you not like that? You must be sick. Something that's socially interactive, which is what we're studying here. Something that's awesome, like the wonderful river outside. And yet, what we do when we do real research is we show things like this. Luminance, contrast, little weird color blobs, or the famous Gabor patch if you really want to be bored. Or if you want to see something moving, we play this kind of thing to study visual motion. Now, you've heard all these discussions about the values and the future of virtual reality. But this is how it all starts. We have to understand how you can see even something as banal and simple as this. So where do we go? Well, traditional brain research has all been about the solo brain, a single brain that we stick into a machine. We stick people into very fancy scanners, by the way, a huge opportunity for the technology community, and then we try to figure out, using very boring stimuli, what goes on in their head. So using traditional approaches like this, we put people into a scanner, and we say, what comes out of their head? And you should see how disturbingly similar this kind of image looks to my lab, which looks like that. This is very worrisome. Now, what we do is in the usual approach, we do very exciting research. Like we stick you in a scanner, and we play something like this. This is where you should start getting very sad, because you're going to hear this for 1 hour. And if I'm in a bad mood, I'll make you listen to something like this. This is maybe for 2 hours. So that's what traditional research is like. And we stick you in the machine, and we try to figure what's going on. And when all goes well, we find data. Like, there's a brain somewhere in there, if you're lucky. Again, if there's not, come see me after the show. Now, the new direction of research is, of course, what you just experienced, which is we study individual brains, but we study them using materials that are natural, like these very moving and engaging screams. That's very different. So we study a single brain in a lab with naturalistic stimuli. So, for instance, what you just heard, something like, or,
oh my God, help me!
all right, that should move you, or even, so that's the experience you just had, something that really grabbed your attention, made you want to do something. Now, why don't you close your eyes? Close your eyes. Tell me your credit card numbers. No. Close your eyes and listen to this. What do you think this is? Okay, open your eyes, look again. So that too works. So there's something very compelling, right? So there's something compelling about the kind of original vocalization, the Urvokalisation or something like that. And you can study that, and my extremely good former postdoc, Dr. Luc Arnal, studied this. And what we did is to try to, in a kind of modern approach, figure out what is a scream, how does it work, and why does a scream hijack your brain like that? And I'm not going to tell you the nerdy science part because it's just too nerdy and too long. But the message is that there's actually a reserved part of sound that's really just for screams. It's not used for communication of speech. It's not used for loudness. It's not used for any other signal, but for signaling alarm or something very intensive. So it has a reserved acoustic region. And that reserved acoustic region, and I kid you not, is called roughness. So there's a region of modulating sounds in the acoustic domain, which is called roughness, and screams, which you see, I'm not going to tell you about what this means, but on the lower left, you see there's a kind of region of activation, those red stripes. That's when a sound is very rough. And the rougher a sound is, you can dial it up, the more scary it is. So we have a specific thing in our heads that you can dial around, and the more it works, the more intense it is. So that's kind of cool. And you can really, so what can you do with it? Well, I can take any sound, and I can measure how rough is it. So screaming is rough, but singing isn't. Alarm signals are rough. On the left side, they're very rough. Any alarm signal, car alarm, house alarm, but other things are not. And the more rough a sound is, the more you judge it as scary or engaging. So I can take a regular sentence, one of you saying to me, will this lecture ever end? I need lunch. And I can play with its roughness, and it will sound scarier and scarier and scarier. So that's kind of cool. Now you can put things in the traditional approach into a brain scanner. So we take you as a victim, we bring you to the lab, and you're lying in one of those machines, very annoying, and we play you these horrible things. And the question is, what happens? And what happens is specific parts of the brain are engaged selectively, and the more rough, the more it lights up. So on the upper left, you see a famous part some of you have heard of as the amygdala, right? So that's like, it's not actually an auditory nucleus, but the more roughness it has, the more it cares. So there is an acoustic signature, a brain signature, and a behavioral signature. So screams really work. So what should you remember from this little mini demo? Well, you should remember that screams hijack your mind and your body. They do something very special. They grab your ears, like Barenboim was just saying. It's the difference between hearing and listening. You cannot help but listen. It hijacks your brain, and it grabs it. And they're very cool, but you have to still do some kind of pedantic, careful science. Now let's go in a very new direction. So that was taking old school, traditional approaches, weird stimuli. Now, cool stimuli and traditional approaches. And now we're going to go completely crazy. So this is where we're going to take some risks. So we're going to now go to the social brain, because what we really want to know is what's going on between us as a group when you're actually doing something together. And this is the work of Suzanne Dicker, my postdoc. So we're going to try to do, this is a bad idea, but we'll do it anyway. We're going to do a demo of brain recordings and brain synchronization. You're never supposed to do a real demo, but we're going to do it anyway. So we're going to bring up our lovely actors that are going to be set up. So while they're set up, I'm going to explain to you what happens here. So of course, we want to see real-life interaction in groups, at dinner, at a conference, and we want to know how can you go from kind of the weird in-the-lab science to in natural state science, which is more engaging. And the way we are thinking about this is to measure brain synchronization between people. Right? So we record brain activity, and we measure online how synchronized the two of them are. So are Arne and Dorothea synchronized? That's the question. And the issue is, if it's a successful interaction, maybe the brain waves are actually synchronized properly, But if it's an unsuccessful interaction, the waves don't align well, as you see in the middle here. So success is predicated on how well the brain waves sync. Now you might think this is crazy stuff, Hexenwerk, but it actually works quite well. You'll see. So what do? You measure in a lab, you would measure EEG with a complicated headset, but you can use very simplified versions, like for gaming, and you measure the waves of the two people, and then you calculate how well they do. And then you can scale that up to not just two people, which is kind of exciting, but still not very exciting. You want to do it in a whole group. So one thing you can do is scale it up. And to give you a very brief example of how this works, we've actually done such a study in New York in a classroom. So we took a whole classroom, 12-Klässler, and we recorded them an entire semester. That is, we had them all wear these headsets, and we recorded their brain activity. So here's how that looks.
Yeah. Oh my God. See it too? Yeah. So those are kind of aligning with these two.
Yeah, it's like on an angle.
I think not the type of text. Are you done?
Yeah, that is, wow. Okay. Yeah, no. But like, if that doesn't work, there's a problem.
Oh, I said it to you.
Let me just, can I double check? Why not? Yeah? Ready? Go.
Facing each other, facing away, and so on. So we did a whole bunch of experiments, control conditions, experimental conditions. And the question is, of course, does this brain activity mean anything? That is, can you interpret it in a non-bullshit way? Right? That's the challenge. Is this just mysticism, or is there something real here? And so one of the things we want to know is, we had the teacher, who was, by the way, a kind of mediocre teacher, sometimes simply read the text. Like it was a genetics class. Read some genetics text, show them YouTube videos of the very same material, give a lecture, like with PowerPoint and so on, or they had group discussions, and then we had many baseline conditions. And the question is, does the brain activity of a group correlate with how you experience what you're doing right now, that is, sitting in a class? And so when we calculate brain-to-brain synchrony across an entire group, is the synchrony predictive of the experience? So what is the experience? Well, one of it is actually the classroom itself. Like, do I like the class? This teacher is amazing, or this teacher sucks. And the other aspect is social dynamics. That is, do I like this guy? Do I like this woman? Do I like the teacher? And we tested both things. So for instance, if I ask you, how much did you enjoy this teaching style? People are different. And people give different ratings. If you're a teacher, by the way, and you happen to be here, you should be very worried that students prefer a video to your lecture. So students really like talking to each other, and they like watching videos. They don't like lectures. What about the synchronized brain activity across the entire group? Well, it's wonderfully correlated with that. So that's actually an amazing result, completely unpredicted. So similarly, how students are synchronized to each other predicts how much they like various things. For instance, they like the teacher. The other question is, do they like each other as a group? So social dynamics, or social psychologists call it groupiness. Do you have group affinity? Like, I like you guys as a group because you came to TOA 16. So we all share something. We're the TOA 16 group. And it turns out that the more you're synchronized, the more you rate each other as a group affine, which is interesting, and the more empathic you are. So you can see there's something kind of deeply interesting and bizarre that synchronized brains across pairs and across groups correlate in systematic ways with your social experience. Now, what is it? So we show that brain synchrony addresses how you like a class, how you like a teacher, how you like the focus, how you like social closeness, group affinity, and so on. Now is the question. Well, first of all, you should be impressed, because that doesn't follow from anything. I mean, that's just an amazing, weird finding. The second thing you should think is this bullshit? Is this Hexenwerk? So is there actually a mechanism, or are you just making something up? And of course, there actually is a plausible mechanism. Otherwise, I would lose my job, even though I have tenure. So the mechanism is likely the extent to which you as a group or students pay joint attention to something. So suppose there's a stimulus that's, let's say like me, kind of medium exciting. I'm not Daniel Bachbohm, I'm just some neuroscience professor. But some of you will listen, some of you will not listen, some of you are checking your email. But those of you, if there's low engagement, that is, you don't really want to be here because you have to go to the bathroom or waiting for lunch, you will be low engaged, you will have low joint attention, and the brain signals will not be synchronized. But if there's a stimulus that actually keeps you all excited, that has the right structure, you will all be engaged, and the brain signal is synchronized. So something as banal, simple as a pacing signal, something that's the same for everyone, synchronizes you if you're paying attention. What's the message of this, by the way? What should you remember? Well, if you're an elderly guy like me, you might say, I thought that the important thing is how related you are to your teacher. The synchrony between you and your teacher should predict what matters. But it turns out the more subversive theory is an interesting one. That is, the extent to which you're synchronized with each other as students is actually what predicts your outcome. So that's kind of creepy. Now, what you should ask, rightly, is, does this work? Can we show it? And so now we're going to do the very, very bad thing of, when we did this in the classroom, we did it over a whole year. We had many people working on it. What we usually don't do is to try to do it on a stage. But we thought, what the hell? Life is short. Let's try it. Okay, so you have to indulge us. This is a high-risk endeavor. But if it works, it's awesome. You must love it. So this is called the Mutual Brainwaves lab demo. It's courtesy of Suzanne Dicker and Matthias Ostlik, and we're going to try it right now. So check it out. Now you need, Yorgos, you now need this thing, right? That's the audio, you don't need that. Okay, so our actors today first had to learn how to scream, which was already pretty exhausting, but they scared me, which was good. Now the question is, can they synchronize with each other? So they are wearing very simple EEG headsets. Each one has 16 electrodes, and we're going to record. You're going to see it, and there you see it. There's one person's recordings right now. You can also see my email, and that I'm messy. Again, I have tenure. So sue me. So both of these signals are going to be recorded, and we're now going to sit here quietly as their brain signals get in and out of sync. So the first part, we want to see how they do with each other. They know each other. They're friends. They are actors together. They just screamed together, and I don't know if it was negative or positive. Can't say. So let's see what happens with your brains. So this is the online signal, and now, as they synchronize, you should see their heads moving. Oh my. Oh, they really like each other. Holy cow. They're completely. Come on, guys, you can beat 60. Okay. Okay, okay, so now this seems to work, right? This is actually pretty exciting. I did not believe this would work. This never happens. Okay, now let's do it once more. So you got a score of 56. Very impressive, very impressive. Good. I don't know what that means. So now we're going to do one more try, but this time we're going to, Eza and I are going to actually distract them. Let's see if you can do it again. Okay, ready? Let's start. So close your eyes. You close your eyes, you close your eyes. And I'm going to whisper sweet nothings in your ear. to distract you. Ready? Also gestern musste ich schon wieder zur Telekom, weil ich hatte mein Handy ist schon wieder im Eimer, das ist unerträglich. Hat mich dieser Vollpfosten da stehen lassen, erstmal für eine Viertelstunde. Dann hatten sie das Handy nicht, dann hatten sie die SIM-Karte nicht. Dann ging das wieder also in die Hose. Dann musste ich mich nochmal anstellen in einer anderen Schlange. Und du weißt ja, wie die sind. Da kriegst du überhaupt nichts auf die Reihe. Es ist einfach ein unerträglicher Scheiß. Dann gehe ich zu O2, das ist die Schlange noch länger, ist ja noch doofer. Dann gehe ich wieder zurück zum Telekom und sagen sie, naja gut, das Handy kriegen sie nicht, aber sie können dann wenigstens irgendwie noch ein Heimtelefon und Fernseher auch noch kaufen. Dann habe ich dem gesagt, ja, geben Sie doch mal Ihre Telefonnummer von zu Hause, dann rufe ich Sie heute Abend mal zu Hause an. Wenn Sie mich schon mal stören, dann störe ich Sie jetzt auch mal privat. Das wäre ja auch was Nettes. Das wäre einfach mal ganz schön, wenn wir uns einigen könnten, dass ganz die simple Interaktion, ein Handy zu kaufen, nicht so eine Krise ist. Weil erstens mal ist das teuer, ich brauche es und es nervt einfach. Also ich weiß auch nicht, wie ich kann ja nicht jeden Tag so einen Quatsch machen. Aha! So it works. Give me the red thing again. I need the red. This. So you're actually able to see, so why is this exciting? Well, it shows you that you can use or not use a very simple, I mean, this is a kind of trivial signal, this is nothing too complicated, to see if people work with each other or not. Okay. So let me come to a conclusion here. This is what we just showed you. So I think there's a nice message to be had, namely, what should you remember from this? Well, first of all, natural signals, like the screams that these guys demonstrated, they hijack your brain. They grab onto your brain and your mind, and they squeeze it and they pull it in. But brain synchronization hijacks each other. Right? So you can hijack each other's minds by being optimally synced, and the way it works is to jointly pay attention. So you can use that in many different contexts. Now, what should you as a tech community take away from this? There are unbelievable opportunities here for development in terms of hardware, software, and the future. You know, if you're really talking about the influence of virtual reality for news or for music, this has unbelievable applications, not just for gaming. That's, I think, slightly boring. It's for the future of communication and news and everything. So take this as a stimulus to go forth. Okay. Thank you very much for coming. Thanks for staying. Thank you to the actors, to Yorgos for helping out. To everyone.
I'm not really sure how that works, but it's unbelievable all the same. Like, yeah, amazing. Thank you very much.
Thanks for having us.
We're going to have time for a couple of quick questions while we just rearrange the stage. So, has anybody got any questions? I don't know how you ask a question about that, but anybody? Just over here on the left.
Yeah.
I'm trying to understand. I don't think it was very clear what they were instructed to do. Were they supposed to think about each other or just...
They weren't supposed to think about anything. They had no instructions. It's simply to focus on each other, look at each other, you know, coordinate something. There were no specific instructions. So a lot of the features of linking are just incidental. You know, if you and I sit across from each other right now, you can work. So you should know that the origin, this demo has been used in a much more systematic and artistically motivated way by Suzanne Dicker and Marina Abramovich. So Marina Abramovich used this for, you know, the artist is present for like several hours of staring at people. So there's actually nice videos of that. But the point is, it doesn't matter. The point is, you know, you capitalize on any little cue that synchronizes you, and you can grab onto that and build on it and amplify it. That's sort of that's the magic of mutual gaze, as it were.
Wow.
Yeah.
Can I buy it, or can I take it home to prove my wife?
Yes and no. The equipment is actually largely off the shelf. The software is, you know, people in my lab develop this sort of thing. Whether you can deploy it for your social life, I leave that up to you. But if you have to ask, probably not.
Just the last question.
Yeah.
Could it be used as a future telephony? Like that, if we know the code or the number of kind of a code or
Yes.
a thought of one person,
Yes.
and then we sync with that.
That's a very good idea. The answer is not yet, but absolutely. I mean, so I've worked on projects of this form in the sense of closed-loop communication. So if I record my brainwaves, I can manipulate them to encode bits. and you know the decoding, I could send you that wirelessly, and you could, so this is obviously used by the army, right? So we record an army person and another army person. We try to decode the signal and send it to each other. So go left, Red Rider, go left, that kind of very cheesy but effective thing. So you're exactly on point. That's sort of the idea, the crazy idea for the future. Where do I go?
Okay,
Thank you very much.
Thank you very much, Daniel Poeppel.
Thank you.